So Chase Lochmiller is building $500 billion, the biggest, it's probably one of the biggest things ever built by humans, right? Like Great Wall of China big.
Well, the universal site is not 500 billion. I think the Stargate announcement was for 500 billion. What's going on in Abilene is about 15 billion in data center infrastructure and probably another 25-ish billion in chip infrastructure on this first phase. So, a measly 40 billion.
A measly 40 billion. Okay. Just a little backdrop on Chase here. So Chase got 2 degrees from MIT. Math and physics, 2 of the hardest you can get, but he got it done in 3 years while being on the varsity soccer team at the same time.
That's right, yeah.
All 3 years.
Yeah.
And then graduated and then decided he's going to climb 5 of the 7 highest peaks in the world, including Mount Everest. And I want to, every time you climb Mount Everest, it seems like, or every time you go to climb Mount Everest, he climbed it once, it seems like there's an epiphany moment and you come back and have some kind of a life-changing pivot. So I want to focus on that in a second here. So he's now running Crusoe, a company that he founded after a very successful career as a quant trader. And Stargate is, announced in the White House in the Oval Office. It's a pretty big deal. Like you said, $40 billion or so of build out in Abilene alone. And then I guess you expand out to other locations from there. So it's probably one of the biggest things going on in compute. And I have a whole bunch of questions about how it's going to play out. So before I launch into Q&A, do you want to just give us your backstory leading up to the first trip to Mount Everest?
So I actually went to Mount Everest twice, and once was in 2014, and then once was in 2018. So in 2014, I guess like my initial inspiration to go to Mount Everest was I had a middle school teacher, and her husband was this blind guy named Eric Weinmeier, and Eric was the first blind person to climb the 7 summits. So and he was actually training for Mount Everest when she was my teacher, so I got to hang out with him a bit, and he was just always kind of this inspiration for me. I was like, wow, this guy's amazing. He's blind and he's going to climb the highest mountain in the world. Like, what an incredible human. I can see, like, I should aspire to try to be able to do that.
I guess.
So, it was kind of one of these dreams that always stuck with me, through childhood and into adulthood. And, I went down on a really cool expedition down in Antarctica to climb Mount Vinson. It's kind of the highest mountain in Antarctica.
Oh, you did that first?
I did that in 2013, and I met a bunch of folks and said, hey, you're a really strong climber. It'd be great, if you wanted to join this trip to Everest in next spring. And I said, awesome, let's do it. It was kind of a.
I didn't know. So I've heard of the 7 peaks,
yeah.
but I didn't know one of them was in Antarctica. So how do you climb a mountain in Antarctica? I can't even conceive of. First of all, you do it in the summer or the southern hemisphere.
Yeah, no, it's a fascinating expedition because you fly in, like, nobody lives in Antarctica year round, right? It's sort of like uninhabitable during the winter.
No kidding.
But during the summer, the sun never sets, so that's like an interesting aspect to it. Which when you're in the mountains, you kind of the sun basically rotates around your head, and so when you're in the sun, it's actually quite a bit warmer, and then you kind of get this wake-up call in the middle of the night when the sun goes behind the mountain and you find yourself in the shade and you get like a 30-degree drop in temperature, and you're I don't know, it goes from 10 degrees to negative 20 degrees, and it's a pretty.
Well, I tell you, my business partner Mark Cassidy decided after he retired from running a public company that he was going to do all these travel things. One of them was visit Antarctica, and so took a private plane from Cape Town, and he's supposed to spend the night. He got down there, he looked around, he said, "Let's go back." It was like there is nothing there. But that's a pretty epic. So I didn't know that.
It's an amazing place. It's actually a desert. I don't know that many people know that. So when you go, there's very little precipitation, and so it's a very it's an incredibly awe-inspiring place. Just kind of this like endless white desert that sort of like rolls on and on and on. So it is very beautiful.
So let's fast forward a year, 2014.
Yep.
This is your first attempt to go to Mount Everest. You get to the Khumbu ice flows. which are the most dangerous, probably one of the most dangerous things you can do. The mortality rate crossing those ice floes and climbing is 1%. Did you know that, by the way, when you went?
I know it's like 25% of the deaths on Everest happen in the Kumbu ice fall, something like that. Yeah,
Okay. Well, it's so in this particular trip, there's a tragic avalanche. 14 people pass away.
Yep.
Is that right? And
16.
16 people pass away. And I think, one thing people probably don't really realize is when you're climbing Mount Everest, it's about a month and a half journey just there, right?
Yeah, I think I was in Nepal for an aggregate of about 2 months.
2 months?
Yeah.
So how long? So one of the things I picked up on your podcast notes was you get a lot of time just there meditating, and of course, after the tragedy at the Kumbu ice flows, you're just physically there for a long period of time. And I noticed right after that, you come to Stanford to study AI, like immediately after. So are those connected events?
Unconnected. It was sort of a pre-planned thing. I was actually enrolled in a Stanford master's program through SCPD. I think that still exists. I don't know if there's folks still around here, but basically I was going to graduate school in computer science, taking classes while working full time. Mm-hmm. I had this non-compete period when I was basically transitioning from, my first job to my second job, and I had this period where I was getting paid to basically not work, and I was like, all right, cool, I'm gonna go on these epic adventures, I'm gonna go to grad school, I'm gonna go do all these fun things while I'm kind of getting paid. So it was sort of premeditated that I was gonna do, I had this certain amount of time for adventure, and then I had a certain amount of time for the Everest trip.
Got it. So you're gonna come here to study AI regardless. Exactly. So what was the inspiration to get into AI?
In the quant finance space, we were increasingly using a lot more AI and machine learning. I think historically we had used a lot of linear modeling techniques, and then we were doing a lot of creative feature engineering that were, I think my background in physics was actually very good for that, because we were trying to model these dynamic systems, right? Where we were saying, okay, this happens, okay, how do you actually represent, how order flows, flow through in that scenario, or how do you expect price impact to play out in certain different scenarios? So, having intuition for how these economic systems would respond to, changes was not too dissimilar from, something that, you're modeling in sort of a mechanical or electrical or quantum system. But over time, I think, we realized that, instead of engineering the features by hand and try to test them out with sort of a linear model that we would fit to it, we could actually sort of discover the features through a lot of these breakthroughs that were happening in deep learning. And, sort of the AlexNet paper was published, and people started to use a lot more GPUs to use these multi-layer neural networks to, do things like, NLP and various computer vision tasks. We started to use those types of things to try to find features that were embedded in sort of the time series financial data that we were.
So then after Stanford, so you come here to study AI. After Stanford, you go right to jump trading. Was going back into quant trading the plan all along, or?
Exactly. So I had actually accepted that job before I.
Oh, really?
Before I left. So everything was premeditated.
What can you tell us about jump trading? Everyone I meet from there is super wealthy. They're all super secretive. I expect you'll say nothing, but.
I'm not allowed to talk about it.
Yeah, okay.
It was a good experience there. I mean, it's a very academic-like environment, but you get paid a lot more than being an academic. Mm-hmm. It was a fun, exciting, place to work. We got to work on hard problems and got to solve them with artificial intelligence and computer science. I think for me, ultimately, it was just not that fulfilling. You're very abstracted away from tangible impact to real things happening in the world. You get to make markets more efficient, but that is actually very valuable. In the abstract, I often say invention of markets is one of humanity's greatest inventions, because it has this pseudo-anonymous way, I can invest in the company Coca-Cola despite not knowing a single person that works there or a single executive, and and I can allocate my personal capital, and I can sort of bet on our shared outcome, being together, that's a pretty amazing invention, like when you think about it. But and so the fact that markets are efficient is like actually a very powerful concept. It just like is not that fulfilling of a problem to work on, like for an extended period of time. So
is that related? So when's the second trip to Everest in this journey? While you were at jump trading?
2018.
It's after jump trading.
After jump trading.
During your crypto era.
Yeah, I had worked at a hedge fund called Polychain Capital.
Yeah. Did you found that? Did they recruit you out of jump trading? Or?
Exactly. So I left Jump and ended up going to Polychain Capital, which was started by this guy, Olaf Carlson-Wee. He was the first employee at Coinbase. Actually, a mentor of mine kind of introduced us. The guy who started GetCo introduced me to the founder of Polychain Capital, and we kind of hit it off, and I ended up joining him as one of his first partners. So. Okay. Yeah.
So where's Everest Part 2 in that?
Everest Part 2. So part of Everest Part 1 is that I had so basically, after the big avalanche that happened in the Khumbu Icefall, one of your major expenses in climbing Mount Everest is actually buying a permit to go climb the mountain. So it's basically once you set foot in the Khumbu Icefall, you need a permit. So once you leave base camp and sort of head up the mountain, so to speak. So because of this tragedy that took place in 2014, they basically told all the climbers that year, like, hey, we're going to give you a 5-year window to use your permit. So like you're allowed to come back. You can reuse your permit sometime in the next 5 years. And so I had a 5-year kind of window to basically try to come back and attempt this. And honestly, it was like one of these things that like haunted me. Like I'd just find myself thinking about, man, I couldn't stop thinking about wanting to go back to whatever calling it was for me to go back to climb Mount Everest. And my wife was like not thrilled about this, right?
Were you married the first time?
No.
Okay, that's a big
I was
difference.
with the same. She was my girlfriend at the time. So.
Did you ask her permission in 2014, or is that not relevant?
Yeah, no, totally. It was like, hey, I want to go do this. She's like, cool, why? But then, once 2018 was rolling around, we were married. She's like, I want to have kids. You're absolutely not going to go after we have kids. That's just insane. So if you want to go, and it's like this thing that you can't stop thinking about, you got to go like now. So it was sort of like 2018 was the year, and we were fortunate to be successful in 2018.
Yeah, I heard you had some trouble with your oxygen along the way.
Yeah. So I think one of the takeaways from Mount Everest was actually, one of the core company values we created at Crusoe was to think like a mountaineer. This is not to say that we expect everybody in the company to go climb Mount Everest, but a lot of the mindset of mountaineering in terms of preparation, resilience, grit, mastery of your tools, and really, frankly, like the resilience of your plans, because as a mountaineer, you really have to plan for things to go wrong, right? Whether it's a piece of gear failing, or the weather changing, or your partner getting sick, or you getting sick, or you being dehydrated, or whatever it is. Like you have to really plan for things to go wrong, and you have to have a plan for when those things inevitably do go wrong. So we always try to think about it as like having a plan A, but also having a plan B, C, D, and E.
Mm-hmm. So you had backup oxygen, I guess?
I did have backup oxygen. The mask, I didn't have a backup mask, but I had to fix my mask. It was kind of like
so your engineering degree comes in handy.
Yeah.
All right, so somewhere along the way, you decide completely shift gears and say, you know what, I'm going to found a company. And I guess originally it was crypto mining oriented, right?
Yeah, so the premise of Crusoe was really building a computing infrastructure business that took an energy-first approach to developing that compute. Mm-hmm. If you look at the landscape of computing infrastructure broadly, like as of call it end of 24, you really have these big hubs, right? You have markets like Northern Virginia that runs the bulk of the internet, and to me, that didn't necessarily make sense for all computing use cases. It like worked very well for serving web pages, but for things like digital currency mining, you'd already seen this mass and today we've seen sort of mass decentralization and distribution compute that is chasing low-cost energy. So it's basically compute going to where they can access low-cost, abundant energy. Yeah. I fundamentally felt that was going to be the way that AI would go, just having experienced.
Oh, this is on founding day. You were thinking about AI as a.
What's that?
On founding day of Crusoe.
Yeah.
AI was very small and new as a compute user compared to crypto mining at that point, right?
It was, but if you took the thesis that, I always felt like intelligence was going to be embedded in every industry, in every aspect of the economy, because what wouldn't be made better by having more intelligence embedded inside of it?
Yeah.
And so, if you sort of take that premise, then, at scale, AI requires, more energy than pretty much everything else in the economy. Mm-hmm. And, energy ultimately becomes the bottleneck to scaling the compute infrastructure to support this intelligent economy.
And so in terms of building compute where there's energy abundant, the first destination wasn't Abilene, right? It was somewhere else?
Yeah, that's correct. So I think the other aspect of this is like when you look at these applications, they're inherently less network bound, and it's more compute bound, which means that the time to get to the data center, like the WAN cost, so to speak, is kind of a rounding error compared to the total compute time that's actually producing a result or an answer inside the data center. Yep. So when we were first building this out, we were looking at interesting energy solutions, and the first big energy resource that we were tackling was something called flaring that happens in the oil industry, where when oil companies drill wells to produce oil, if they don't have access to a pipeline, they actually produce natural gas as an associated byproduct. And if they don't have access to a pipeline, they actually just burn it off. And this is actually one of the worst environmental problems in the world, because when they burn it off, not all of the methane gets fully combusted. Yeah. Methane traps 84 times more heat in the atmosphere than CO2. And it's just like I think it accounts for about 3% of total greenhouse gas emissions globally. And it's like nobody's benefiting. It's like this complete waste. So we actually came up with this concept that we could actually do something beneficial with that waste product by actually co-locating.
The numbers on that were mind-blowing too. Because when I heard that originally, I'm like, yeah, and people want to catch cow farts too and turn it into like so what? Yeah. But then it's like I looked it up on the internet. It's like 14.5 billion cubic feet per day. 20 gigawatts of just thrown away energy that turns into...
I think 60.
Is it 60 gigawatts?
60 gigawatts.
I just asked Gemini and gave me the wrong answer.
Yeah.
Holy crap. So how did you even here you are, you're quant trading. How do you even know that?
So my co-founder was like facing this problem directly. So my co-founder, Cully, is a guy that, him and I actually went to high school together. And he had sort of spent his career in various pursuits across the energy industry, ranging from geothermal power plants in Iceland to sort of studying coal power plants in China, to the domestic oil and gas industry here in the United States. One of the issues he was dealing with was actually this problem of flaring, and he had like a lot of like moral guilt, honestly, when he was like burning off all this gas. He's like, this is unbelievable. Like I can't even find someone to pay to take this gas. Like, this is just like a huge problem that's plaguing, both our economics of the site as well as the environmental impact of the site. So it was something that he was struggling with, and him and I started discussing this. And when I sort of learned about this problem, I'd never actually set foot in an oil field. And I was really like mind blown, when I kind of saw it firsthand with my own eyes, like seeing these giant fireballs lighting up the sky, saying like, how the hell is nobody using this, or how is this even legal? Yeah. We came up with a solution to the problem.
So it's pretty capital intensive though to just jump ship from quant trading and say, hey, I'm gonna capture this flare off gas and turn it into compute. It's going to turn into AI. And obviously it worked, and you've got a ton of grit. But not a lot of people would take that leap, right? I mean, it's pretty serious. So how do you end up in Abilene from there? And how did you even fund that?
Yeah, so I mean, Abilene was kind of I think we were growing the flare mitigation business. We ended up actually selling that business earlier this year. But at the point of sale, it was a little over 200 megawatts in total. Off-grid generation capacity to support flare mitigation. But the way we landed in Abilene was actually, Abilene is another market that it has this underutilized stranded energy. And it really stems from this fact of it's one of the windiest areas of the United States. You have the kind of this whole corridor, that goes through Abilene, where it's been a highly economic proposition to actually build and develop large-scale wind farms. But one of the big challenges they had was actually lack of demand for power. So generation was very, very efficient. Some of the best capacity factors of any wind farm in the United States, but lack of demand. So AI is obviously a natural fit where it's one of the most energy-intensive demands that is sort of looking for low-cost, abundant power, and just like another manifestation of this thesis of we should be building compute where we can access low-cost and abundant power, not where we have these previous data centers that just live that are serving web pages on the internet.
Yeah, no, it's ridiculous. I didn't know a lot about this until recently, but I've been talking to our governor in Massachusetts here, back in MIT territory, and we have talent everywhere between MIT, Harvard, BU, BC, Northeastern. It's like all right there. Like, why don't we put the compute here? Like, okay, well, in West Texas, you have sun, you have wind, and you have oil, and you have very low regulation. You can put nukes there too. Everything you could possibly want. What do we have here? Well, none, no, and no. Like, okay, this isn't gonna work. And so you run into this red state, blue state kind of problem, but it's like so obvious that the racks clearly belong where you are. The talent that wants to tap in is right here at Stanford and Silicon Valley, and also back in Cambridge.
Yeah, I think one of the big realizations of the business over time has been that moving data is a lot easier than moving power.
Yeah.
Or moving gas, or moving the energy side of this, just a lot more complicated than moving the data side of it.
Yeah. So when you talk about what you're doing in Abilene, do you call it Stargate? Do you call it Crusoe? What is it? Okay.
We'll call it what, I don't know.
All right, let me ask you the tough question. So if you look on the internet, there are lots of great videos of you and Sam Altman walking around, and it's just. I took a tour of the biggest facility in Massachusetts, and it was immense. And then I look at the scale of what you're building, and it's about 2 orders of magnitude bigger. I can't even picture. Actually, we're going to come to Abilene and check it out if that's okay.
Great.
Peter and I will
come down.
Tour around. Do you want to do we'll do a podcast on your
Yeah,
turf?
let's do it.
All right. Well, so if you look online, you can see, so Chase and Sam Altman walking around inspecting everything. It'll be online pretty soon, right?
There's a bunch of stuff online now, but
is it? Is it all NVIDIA in the racks, or what is it?
So it's primarily NVIDIA is the primary chip provider in Abilene. Yeah. So it's Blackwell chips, so it's GB200s that are being built there.
And what's the long-term plan? Is AMD gonna kind of muscle in, use the MIT connection, or how's it?
Not in Abilene. Abilene's actually designed to be, so it's 1.2 gigawatts of aggregate power. It's designed as it's essentially designed as a one contiguous cluster. Mm-hmm. So it's actually
for training, basically.
Yeah, for training, or eventually it'll be. I think it'll be training initially, but also post-training, test time compute scaling. As kind of the initial model is trained, but it is. It's really. Yeah, it's designed as a gigawatt scale computer. That's how I think about Abilene. It's one cohesive unit, one cohesive brain that is more than a gigawatt in capacity.
So not to get too deep into the Elon Musk, Sam Altman drama, but I have to ask. So you're backed at least in part by Valor, right? Mm-hmm. Which is the great Antonio Gracias, great guy, who has invested in every Elon Musk thing and every article. They're joined at the hip. I think OpenAI is the customer for Abilene, right? We were there a couple weeks ago, and they're dying for that thing to come online, and they need the compute like yesterday. How does that work? Like, are you neutral in the great
I think, yeah, I mean, Crusoe itself, I mean, we're an infrastructure provider, so we're really rooting for the space to, transform people's lives and, bring benefit through all of these breakthrough innovations driven by AI. But we're not picking sides. I mean, we've been a very large partner to, multiple different labs.
From Abilene or in different locations?
Other locations, Abilene. I mean, we kind of view it as like anybody that wants to be in the race needs an Abilene scale facility. We can help support that. Like it's not, we're not trying to, pick winners or pick sides or any of this. We just want to help people out. The same goes for, on the silicon side for Crusoe Cloud. I mean, we support, both NVIDIA as well as AMD. We're a big launch partner with AMD around the MI355X. And a lot of that's driven from customers coming to us asking for choice. And, we want to be able to support choice in the ecosystem. We also think about that way with capital providers, right? We don't have one single capital partner. We have, many capital partners across the industry.
What's the total cost of building out, Abilene, but across all your locations?
I can't really speak about all of our locations, but I would say that over the next few years, we'll spend more than $100 billion.
$100 billion?
Yeah.
Big. So if it's all NVIDIA chips, NVIDIA has cash, like hordes of cash. And then the customer, OpenAI is the biggest customer. They have a huge capital raise going on. Do they prepay for any of this and fund you, or do you actually have to raise capital on top of that?
So I think it's important to note, like our customer for the facility is Oracle.
Okay.
It's us, Oracle, OpenAI.
So you go through, so then OpenAI buys it through Larry Ellison, which is why he's in the Oval Office making the announcement too, I guess.
Exactly.
Why weren't you in there? Why weren't you in the Oval Office that day? Building it.
Trump forgot to text me, I guess. I don't know.
That's a big oversight. Did you ever think, like when you were, quant trading, that you'd be looking, like you had a hard hat on, there's concrete flying around everywhere. It's all liquid cool. The amount of pipe is just mind-blowing.
Yeah, I would have not guessed that I'd be building, extraordinarily large physical infrastructure. But I think it's one of the most important bottlenecks to scaling this technology wave. And I'm very honored to be in the position to be able to help support that piece of the ecosystem.
$100 billion. Well, we only have a couple minutes remaining. I'd love it to be used inspiring people who are back at MIT right now. The amount of entrepreneurial energy is like nothing you've ever, you saw it in, I guess, 08 or 07 because you graduated a year early. It's just gone through the roof since then. And I mean, so everybody on campus knows who you are, knows your name, is watching the videos of you with Sam Altman walking around. So any message on just, you're kind of the great leader in grit. The things that you've done, the risks that you've taken are next level versus virtually anyone that I've seen. So what inspirational message could you give back to that crew?
I think in a lot of ways, like I wished I would, hindsight's 2020, and easy to kind of say this today, but I wished I would have done something entrepreneurial sooner, because I think especially if you've become accustomed to being successful in your life, whether it's like you got great grades and great test scores and you got into a great university and you've kind of like always had this career that externally sort of looks very successful. I think there's a fear of failure, so like you feel like you need to go to the next thing that makes you appear to be great or appear to be doing the right thing. Yeah. And part of the entrepreneurial journey is failing. Like you fail, probably way more than you succeed, but your successes end up becoming far bigger than your failures. Mm-hmm. And so what I would say is just don't be afraid to fail and don't be afraid to take big risks, because ultimately what comes out of those failures and what comes out of those big risks you take can be well in excess of any sort of failure you run into.
One last question. So now you're married, you have kids, 8 kids?
3 kids.
You have 3 kids.
3 kids,
But
yeah.
there's still 2 mountains left on the Big 7. How's that going to work?
They're on the list. They're on the list, along with a lot of other things. We'll get to them. We'll get to them. Yeah.
Chase,
Great.
it's been such an honor to have you here today,
Yeah.
and keep inspiring everybody.
Thank you so much.
Great.